Okay, just one more quick example of a Snell's law problem here. A set of wavefronts has an angle of incidence of 30 degrees when it moves from shallow water to deep water. In the deep water, the angle of refraction is 45 degrees. If the wave is traveling at 0.6 meters per second in the shallow water, how fast will it be going in the deep water? So we have it we want to know what the velocity in the deep water will be. We have the velocity in the shallow water. The velocity is inversely proportional to refractive index. So when I set up my ratio here, I set it up where the VD on the top maps to the refractive index on the bottom. It's inverse. And same thing with the refractive index for the shallow water. Inverse to where it is with the speed of the wave in the shallow water. Now with that in hand, I need a little bit more information because this is the only one I know right now. But I can use my angles to get this ratio. So let's go ahead and do that using Snell's law. Refractive index in the shallow times sine of the angle in the shallow is equal to the refractive index in the deep times the sine of the angle in the deep. It says when it moves from shallow to deep. So 30 degrees is in the shallow water. 30 NS. And then it says that the angle changes to 45 degrees. So that's the angle in the deep water. And as I can see from my equation here, I want shallow over deep. So I'm going to bring my refractive index of the deep to the left-hand side of this equation. And then I will bring the sine down on the right-hand side. Okay, with that in hand, okay, so we have the refractive index of the shallow water over the deep water. That's our ratio here. Sine 45 divided by sine 30. And we get 1.41. So now that we have that ratio and we have the speed in the shallow water, we can find the speed in the deep water. That was 0.6 meters per second in the shallow water. That's shallow, didn't it? Yeah, okay. And that's 1.41. That's that ratio. So the wave would speed up as it went into the deep water and move up to a wave speed of 0.85 meters per second. So that's just another Snell's law problem where we look at how we can use two refractive indices to figure out the change in speed that would be associated with moving from one medium to another medium.